Hey guys, thanks for showing up. I'm doing a demonstration here. I'm going to try to keep it simple. A couple of years back, I unloaded my vintage computer collection and plugged it in and went, this is really cool. What on earth can I do with this that's actually like really cool and is inherently part of the nature of the beast? So for example, I'm not going to crack this out and run spreadsheets on it. Like, that would be cool for like 5 minutes. But after that, it's just, there's no intrinsic value in doing productivity software on old computers. But music is cool. Music is unique. And music and art on vintage equipment has part of the nature of the item, of the electronics, of the sound, of the way that it looks that's unique and valuable and timeless. So between that artistic value and the problem of e-waste, I've had this, last 5 years journey of trying to get as many cool ideas out of as many old pieces of technology as possible. That is a topic for a different time. One of those projects has been PETSynth. So a few years back I came out with PETSynth. We'll call it version 1. I think it was alpha version 0.7 to be honest. That's fine. That was very, very quick and dirty. The next version is what I'm going to be showing you today. This version of PETSynth, to make a long story short, is me reworking PETSynth to be more modular, easy to extend, easy to write effects, easy to do cool stuff. So I'm going to walk you through some of the cool effects that are possible out of this machine, and then I'm going to do a little demo with a track that's made up of some Commodore 64 synth pieces, and some symphonic stuff, and some drums in my Amiga. But first, let's look at some of the sounds on here. So, the PET has a chip in it, the VIA 6522, or 21, I can't remember. Anyway, essentially there's a shift register in there. Shift registers go from parallel to serial. What we're doing with the PET is we're setting a very basic 1-bit pattern, and we're manipulating that pattern, and we're using the clock rate of that shift register to make our pitches. Great, so what? What does it sound like? Well, it sounds like this. So, what can we do with this that's interesting? I'm going to take you through the effects that are new to this software, that are different from the first version of the software I wrote. So, it's going to be difficult to do this with one hand, but I'm going to do it anyway, alright? Please bear with me as I try to do my crazy keystrokes with the PET. No, I'm good. I'll figure it out. It's fine. Thank you. So the first thing I wanted to do was a really cool pulsar effect. This is changing the waveform, kind of like pulse width modulation, yada yada yada. This is what it sounds like. So the other thing you can do is I've created some LFO modules. These are low frequency oscillators. I use these to affect some of the parameters of these effects. So let's take this and make it faster. Or slower, sorry. Or you make it faster. Or I believe 1 step faster. Gets a little mangled. So that is the pulsar effect. Let's turn that off, and I'm going to show you another one here. By the way, this is so alpha, this is probably the worst user interface ever. So there's nothing to see here. I'm not even going to show it to you, it's horrible. Let's go for vibrato. Now again, we can use our LFO in this case to make it faster or slower. So let's try this out here. I'm gonna have to put the mic down for this. So that's some variations on the speed of the vibrato. I'm going to head and turn that off and show you another one here. Now, a lot of cool software out there has an arpeggiator. I got a little lazy and I wanted to do something simpler. Instead of doing like chords, I just wanted 2 notes. I call it the note jumper, so I didn't have to type in arpeggiator when I was coding it. I'm not going to lie. So I've got fifths here, so it's going between the 1st and the 5th. That's it. So you can also change the speed of that. I'm going to go ahead and do that now. And I'm going to speed it up. When you get this fast, it gets mangled. It's kind of cool. All right. You can also change the note. We're going to go do that right now here. Here we go. So I've got an octave right now. Notice on the PET that the really, really high notes sound really out of tune. That's because we've got very low resolution on the tuning. You can get like 3 good octaves out of it, that's it. Also, it's kind of cool. No, it's not. That sounds pretty bad up there. It's kind of cool. All right. I'm going to go ahead and turn that off. And we're back to our just solid tones here. So now I'm going to play a track. This is a track I mentioned at the beginning of the presentation. It's got some Commodore 64 synths, some symphonic stuff, some Amiga drums, and I'm going to play over top of it with the PETSynth here. And then I'll open it up to questions. All right, rock and roll.
you only have one voice on the pet?
Yes. Sorry, I just want to make sure I don't start playing something else and blow us all away. Yeah, the PET has only one voice. I think originally when the PET was designed, it had this interface chip that happened to have a shift register on it, which happened to map to a user port, which somebody happened to go, hey, let's make music with that. So on the subsequent PETs, they put a piezoelectric speaker on it and went, hey, here's your effect. So that is, yes, just one voice on the PET, unlike the SID chip, which has three.
And then,
go for it.
This thing is nothing more than just a switch that you're flipping on and off.
No, actually, the shift register has 8 bits on it, 8 parallel bits, and that makes a waveform. If you can imagine this as a waveform, you would have 8 bits this way and 1 bit this way. So you're able to define waveforms that are only 1 bit tall, but you've got 8 bits of it to do that. So I'm manipulating the pattern that's placed into the shift register to do all my effects. So for instance, with the pulsar,
they're only 1 bit high?
That's correct. They're only 1 bit high, but I'm not just flipping 1 bit. I'm actually treating the shift register the way that you would treat an oscillator on the 64, on the SID chip. I'm writing my wave pattern to it, and I'm manipulating that to create most of these effects, or changing the pitch. Anybody? Anybody else?
So you're still having either 0 or 5 volts coming out of the battery.
Yes.
You're changing the pattern of that 0 or 5 volts.
Yes, that's correct. So the output will only be either 5 volts or 0 volts. So that's the 1 bit of height of resolution of the output there. So the pattern is over time either just on or off. That's it.
Sort of like pulse width modulation?
Yes, but unlike just regular pulse width modulation, you can actually have more complex patterns. If I had a marker board, I could show you. I hadn't thought of that. But, so, for example, I'm going to show you a different effect. Instead of the pulsar, I'm going to show you the pulse mangler, which was a bug that turned into a feature, which will write more interesting patterns to that shift register. So, one sec here. So let me turn off the old one here. So, and then we're going to mangle it here. So in that case, instead of just manipulating the pulse width, I'm writing all kinds of random crap to that shift register, which is making a more interesting sound. So you get different harmonics when you can, for example, have a wave that's like, you know, the first 2 are up and the second one's down, and then one's up and then one's down, and then 2 more up and 2 are down. So you can do a lot of interesting things with this sort of 8 times 1 bit, you know, wave table, if you will. So it's a little bit more interesting than pulse width modulation, but you can definitely do that too.
And what's the highest frequency you can output?
The highest frequency on the PET is, okay, thank you. Oh, all right, yeah, let's do this. So the highest frequency on the PET, wait a minute, it's like, it's supersonic, so it's like, it's above 20 kilohertz, but everything useful, is that true? I'd have to look it up. You get a single 8-bit spot in memory for pitch. So your lowest frequency is actually fairly high. In fact, that's as bass as it gets, using it as is. There's other things you can do with like manipulating bits and things, but effectively that's as low as it gets, and as high as it gets is yeah, it's definitely over 20K.
What I'm thinking is, if you have really high frequency, if you were to put a simple circuit on the output, if you had 3 ones in a row, 5 volts, that could accumulate. So if you were to maybe count the number of bits in a given time period, either with maybe a capacitor and a resistor combination, or maybe a digital thing, you could then actually get your serial back into parallel. So you might be able to get 8-bit resolution
Yeah, and in fact, there are a number of add-on boards for the PET that do lots of those kinds of tricks.
But you'd be losing your 8 times frequency. So in order to do 8 kilohertz tone, you have to produce a 64 kilohertz stream.
Yes, no, absolutely, yeah. No, that's a great idea, and like I said, there's a lot of like add-on boards for the PET that were made that do various things with the sound. My goal was to just take a stock PET, and other than plugging the sound into a mixer, using it sort of as is, without you know, doing funny things on other pins to get more voices or anything. I mean, you could do that on Commodore 64. You could use the user port and toggle all the pins and do crazy stuff and have like 20 voices, oh my god. But that wasn't my goal. My goal was stock PET, what can we do with it? So, and this is version 2 of that effort. Got a chart here. I'm going to kind of show you, for example, the kinds of things you could do. So we're going to go like that, and we're going to go like that, and we're going to go one of those, and we're going to get one of those, and we're going to go one of those. And then, so for example, actually we could even, so here you go, along the bottom you've got your 8 bits, and then your 0 and your 1 there. So what we're doing here is, these are the 8 bits that get fed to the shift register, and this is the output when it goes from parallel to serial as it loops over and over again. So unlike a regular pulse width modulation, I can have the first one can be on, the second can be off, we can do 2 ons in a row and then another one, and come up with all kinds of crazy patterns. So, you know, we could do a pattern that's just like this, or we could do like a pattern that's like this, but we could also do crazy patterns like this, and then, you know, something like that. Or you could do, you know, like that, and then like that, and like that, and then, so there's a lot more that you can do than just your typical pulse width, which is either this or this. So again, these are your 8 bits here, and this is your 0 and your 1. So, and then the shift register, effectively, is a device that looks like so what you'd have is your inputs here, you load up the bit pattern that you want in here, and then this is the output, so we're going from parallel to serial, and then this goes like this as your output, and then here, your clock, that's actually another spot in memory that there's a timer on the VIA. It's like, there's 2 timers. There are 8-bit timers, which is why the range of pitches you have is kind of crappy. But whereas on the Commodore 64, they're 16-bit, so you can actually get things in tune and get a decent range out of it. But basically, we're taking the shift register, we're writing our pattern in here as I laid out in this diagram. We decide the pattern we want, we feed it into the shift register, we set the frequency in memory, feed that into the clock of the shift register, and then our output will be the pattern that we specified here at the rate of the clock that we set here. So that's the quick and dirty of it. I'm sure you don't want any more detail than that, but that's essentially how it works. Anything else? Go for it.
The clock frequency of the CPU is what, 1 megahertz?
Yeah, something like that, whatever the stock 6502
and that
is.
thing's probably a division of that 1 megahertz.
Yeah, that's what the 8-bit division is. It's, is it? There might be some other stuff going on, but there's essentially 2 8-bit timers on the VIA, and they're driven as derivatives of that 1 megahertz clock. I just can't remember if they're like clock divided once and then, or like, I'd have to pull up the specs, I can't remember.
But you know you can get, like you said, over, you think you can get over like 20 kilohertz.
Oh yeah, definitely, yeah, because it wasn't intended to be a timer for audio. So there's no reason to have extremely low frequency clocks. You know, the idea would be you drive some external piece of hardware. So if you had like a modem or something, you could drive the clock of the modem clock by setting your timer and whatever. Or if you have like crazy pulse width stuff, you know. When Chuck Peddle designed these chips, he had a vision of being able to connect all different kinds of hardware. So he created the VIA and the PIA and the SIA and all those chips in concert with the original 6502 to be able to drive external hardware. And so when they designed the PET, they tried to, I think, open up as many of those features of those peripheral interface chips as they could so that you could do cool stuff. So, yeah. So yeah, there's no audio use for extremely high frequency stuff, but it would be useful in driving like a modem, you know, like a 32 baud modem or something. What's up?
You could write a program to call your dog.
Yes, yes, you could. I'm not sure what the frequency range of the piezoelectric speaker is, but piezoelectrics in general usually go very high in frequency. So yeah, you could totally annoy the hell out of your dog. Definitely.
Yes.
And in experimenting, I've created some horrible sounding things. So yeah, I can get up there. All right. Anything else? I'm the last show of the day, so we can have all the questions we want. What's up? Yeah. So the pulse mangler and the pulsar effect in this version of PETSynth changes the waveform over time. In the original version of PETSynth, I actually had one that would just randomly write random values to that shift register.
That would be kind of giving you a white noise effect-ish?
It was white noise-ish, but it would be affected by the frequency of the note that you were playing. And so I had a collection of what I thought were drum sounds that kind of came about through manipulating that. I can show you guys some of that from version 1 if you want to hear it. All right, let's do it. I should get a video outboard and then I could put it into the thing. All right, so let's show you this one. So with this program, the length of the note was set because at that point I didn't write any kind of keyboard scanning routine. On the newer version of PETSynth, I'm reading the keyboard as quickly as possible and not debouncing in any way, which makes the user interface ridiculously horrible to use. So we're alpha here, we're not even beta. This is why I haven't put this on the website yet. The first version of PETSynth was open source. The second one will be, of course. I just haven't put it on the website because it's pretty crusty to use. But you know what? I'm sure you'd appreciate it, so I'm going to throw it up there soon, warts and all. Let's see here. Sorry, it's been a while. I got to figure out which one does this. Here we go. So right now I'm writing random values to the shift register waveform pattern as I discussed. They're not truly random, so you can actually hear that whatever random, pseudo-random cycle it's going through, you can actually hear the repetitive nature of that cycle. But I changed the note length to be really, really short, which is what gives you more of a percussive sound. So random waveforms, kind of noisy, kind of mangled, make the note short, boom, drums. Or I just tell people it's drums and use it like drums and it sounds like drums. It's probably just like a mess, but it's great. So there's some crazy drums for you.
So between the two of those sounds that you were playing back and forth,
Yeah.
it's just a pitch difference, right?
Yep. So
Different pitch fed to the chip.
that's correct. So what I'll do is I'll make the note length a little longer so you can hear it. So here's the lowest note. And then higher notes. So I'm just going to play a scale. This is actually when you write...
I like it up at the top.
Okay, this one's weird. There's like a glitch, which I haven't fully investigated, but when you look at this waveform, it has more than like 0 volts and 5 volts in it. I believe that when I'm writing to the shift register, there's some noise when it, like when the latches engage and write to the thing and then disengage. there's some weird noise that's like some function of that waveform. I can't figure it out, but it just sounds really cool, and it's I think open to the possibility of creating like 4-bit digital sound, because you can hear that. That's not, you know, like that's some harsh stuff, but so that pitch is actually, we're writing a 0 pitch and we're just manipulating the waveform at 0 value for your pitch. So I have to figure out what to do with that because there's something really cool to be done there.
When I was reading some stuff on the 64, I'm not sure if it applies to this,
Okay.
but some of those CIAs and all those different chips and registers, they have a certain amount of time before they can ramp up to full 1 and ramp down to 0. So you might be catching them in the middle of that, and that's why you're getting it.
Yeah, that's great. I hadn't thought of that. That's probably hugely insightful. Thank you. Yeah, I'd love to figure that out. So, I mean, we get busy with our day jobs, and I haven't touched this stuff in a year, so. But that was definitely an avenue I wanted to go, and that makes a lot of sense now. Cool. Any other questions? Anybody? Bueller?
Can't sample.
Sorry?
Take a whole string and create a waveform. So like a sample based.
Okay, so you could sample. You could. It would be 1-bit samples, and what's his name? He did that. I have it, just not here.
Yeah, they did it on the PET.
Yeah, they did it on PET. So basically, radio operators and like radio technology for a long time would take the audio signal of people speaking and compress the heck out of it. So they would effectively make the volume either maximum volume or 0 volume. And so in doing that, you can still understand what people are saying. It just sounds like really horrible. Like imagine the worst CB radio you've ever heard in your life. It's even worse than that. But you can do that on the PET. You can record something, and I've seen someone who actually did this also on a PIC microcontroller to do speech, I think. But on the PET, yeah, you could record 1-bit audio and then play it back that way. I would probably just pick another, I would probably just like flip the bit on and on. That would probably be easier. Because you'd have to write 8 bits and then wait. Well, you could do that. No, there's a way to do that. There's a way to do that with that chip. You can see when normally when you're doing sound, the shift register is going over and over and over and over again. There's a way to set it to not do that. That's called one-shot mode. You can turn that off, and then you can feed it in 1 character at a time, and it would only play those 8 bits and then stop. So if you're feeding it a regular diet of bits, then you could have, you could have fully recorded sound. 1-bit, recordings. They sound really mangled. It's cool. So I forget now what that was, but there was somebody that made a speech program for the PET that actually they had sound recordings, like the phonemes or whatever. They recorded them into I think basic data arrays. Like they just had it all just in there, and it would make the PET speak. And if somebody told you what the PET was saying, then you would hear, oh yes, that's what it's saying. Other than that, I wouldn't want to do anything where that's important that you know what the PET is saying. But it was pretty good. Yeah, I wish I brought that. That was fun. Any other questions? I'm here all night. I got all night. All right, thank you very much. I hope you enjoyed it.